Good afternoon to all. I'm of Engineering and Management Amravati for giving me this opportunity to with you all. Let's start with a presentation, structural planning and design. Structural planning is a most important and for me, first important thing is we must have information regarding the structures for which we are doing the design. There is a long checklist from which will consider various aspects. The first aspect is regarding the soil consideration. Yesterday, Dr. Pusatkar has already explained you the things, so it is just a revision. So we must have a knowledge of saving capacity. Soil investigation will be done, and we will be having the reports for we'll be having am I audible?
Yes, sir. Audible.
So we must have safe bearing capacity of the soil. Then we must know at which depth this capacity is groundwater table and contour map for site. That is where there are some undulation in the site. So we'll discuss these 2 points: groundwater table and contour map. Now, effect of high water ground table is important. Now you can see here one news. See this particular basement, which was at this level, it is lifted by about 15 feet. So this is because of high groundwater water. Now there is a need of parking, and multi-level parking is provided in most of the structures. Now let's study what is the effect of groundwater table. Now this is some small plan. Let's consider that during rainy season, this is the groundwater table, which is 4 meter to the base. So naturally, there will be uplift pressure of 40 kilonewton per meter square at the base. Similarly, on wall, there will be water pressure of 40 kilonewton per meter square, and in addition to that, there will be soil pressure. So, if I consider 10 meter by 10 meter size of basement, then area will be 10 meter by 10 meter, that multiplied by uplift pressure of 40 kilonewton per meter square. So there will be uplift force of 4,000 kilonewton, that is 400 ton. In the initial stages of construction, if you calculate the downward load, then that will be due to weight of foundation, weight of raft slab, etc. But this 400 ton or 4,000 kilonewton is quite a heavy load. If such a heavy load is not available in downward direction, then uplift of basement is possible. And to avoid uplift, this uplift of basement is possible Now, in case of basement, this is the basement. So these retaining wall, whatever retaining wall which are there, they must be designed for horizontal pressure, which will be due to water pressure and soil. So because we want that this basement must remain dry, these all section, say base as well as vertical walls, this must be designed as a crack-free sections. And for that, the requirement of a steel as well as thickness will be quite large for crack-free section. So this groundwater table plays most important role in design of basement. During initial stage, when sufficiently downward load is not there, then we'll have to provide some safety walls, etc., so that we can take the water inside and uplift can be prevented, so that structure will be safe. After constructing, say, number of stories, sufficient downward weight will be there, and in that case, there is no problem of uplifting. Now, another thing is contour maps. We must have a contour map for site. Say this is one photograph. Now on right hand side, this is the ground level, whereas on left hand side, there is a drain. So there is a quite level difference between the soil on left hand side and right hand side. Naturally, this wall will be subjected to earth pressure. Even if this height is, say, 1.2, more than 1.2 meter, then large horizontal pressure will be acting on the wall, and there are chances of overturning of this wall. Now you can see slight tilting of wall is there, and in this particular photograph you can observe the crack at the center. Now during rainy season, there will be water pressure in addition to the soil, and in that rainy season there are chances that this wall will be easily overturned. So we must know the contour map, and depending upon the height of pressure, uh, height of soil, we'll have to calculate the pressure, and accordingly retaining wall will be required. Many times plinth height is quite large, and there are cases when there was overturning of plinth because of large pressure. So we must understand the pressure, the effect of pressure, and suitable measures must be taken. Then another checklist, say we must have all functional plans, elevations, various cross sections, plinth height, floor to floor height, sanctioned drawings and working drawings, because many times there is a difference between the sanctioned drawing and working drawing. So we'll have to construct as per the working drawings. So you must know what are the working drawings. Scope for future expansion. Uh, Now, many times there is an increase in FSI, so we must have scope for future expansion. Sometimes owner want to purchase TDR also, so these points must be discussed, and what are the further expansion possible, that must be kept in the mind while designing the structures. Then, for considering the loads, we must know type of outer wall and its thickness, means whether it is ALC block, normal brick. So these we must know, so that loads can be considered. Similarly, thickness of inner wall and its type of inner wall and its thicknesses, side plan and marginal distances. So if there is no marginal distance, then we have to design an eccentric footing. Marginal distances can be used for water tanks and other facilities. So we must know what are the side distances available. Special architecture features, if any. Now, generally, full architectural drawings are not prepared. Initially, some functional drawings are prepared, and then later on, architectural features are developed. This is not a good practice. It might create problem. Now, this is one of the building where initially architectural elevation was not developed. Later on, he has prepared some feature, and contractor himself constructed architect this small. You can observe here, cantilever slab is quite large. The slab is quite large, and it's not stable. So they have to provide temporary support for stability. So what is we must insist to architect and owner that architectural drawings, 3D drawings and walkthrough must be prepared at the initial stage only, so that we can take into account all features, and accordingly provision for structural design can be made in the initial stages only. Otherwise, it might be dangerous. Now we must study the details of staircase, such as grade, riser, landing, availability of headroom, etc. Otherwise, there might be some problem. You can see this staircase was designed, but what is the use of this type of staircase? So we must be very careful. So architect might design these, but you must verify whatever things which are prepared, they are correct or not. Otherwise, the entire team will be blamed. So if any errors are there, then we must suggest so that the problem can be rectified at the initial stage only. Position of lift and other details. Then position of overhead water tank and its capacity. Because we will have to calculate the weight of water tank. So we must know the position as well as capacity of overhead water tank. Position of underground water tank and its capacity. Then sometimes septic tanks are required. So we must know septic tank and its location. Nowadays, solar power is popular. So if owner wants to construct solar power, then we must take into account the load of structure for solar power. Then generally architect will give us the tentative positions of column and beam from the functional point of view. So that must be seen, so that repetition of design will not be there. Then type of water closet, that is a sump requirement. Now we'll have to provide sump in WC and bathroom portion, so that the floor will be flush. MEP drawing, this is most important. That is the mechanical, electrical and plumbing drawings. Now we want some cooling system, air cooling system. So a lot of ducts will be required. So if we do not plan properly, then later on there might be problem of headroom and many other problems. So we must have coordination with this MEP designer so that the future problem can be minimized. Firefighting plan. Nowadays, for firefighting, there is a huge requirement of water. So we must know what is the water requirement for firefighting. So separate water tank is required, overhead water tank is required, as well as underground water tank is required. So because if you don't consider this in the beginning, then the weight of water tank for firefighting will be very huge, and that might create a problem. Then grade of concrete and steel. Now instead of going for minimum grade M20 and Fe415, it is always better to go for higher grade of concrete. In case of higher grade of concrete, the increasing cost per cubic meter will be very low, but there will be a lot of saving because lesser cross sectional area will be required for the columns, and the amount of steel required will be less. Then we'll consider types of structures based on transfer of loading. Now, load-bearing structures are common and oldest one. In case of load-bearing structure, we know that load from the slab will be transferred to the wall, and from wall it will be transferred to the foundation. And in case of frame structure, we already know that from slab load will be transferred on the beam, and from beam it will be transferred in the form of reaction to column. From column it will be transferred to the footing. Now, this is the example Hotel Taj at Mumbai. This left-hand side building is a load-bearing structure constructed in 1907. So more than 113-year-old, and still it is serving the purpose. On right-hand side, whatever building that is New Taj, and it is a frame structure. Now there are monumental load-bearing structures at Fatehpur Sikri. This is Panch Mahal. Now you may feel that it's a frame structure. We can call it frame structure, but it is a stone. These columns are of stone, and these beams are stone beams only. It is constructed in 1770, almost 450 years ago, but still it is in good condition. This is 5-storied, we can call frame structure, but there is no RCC or steel, only stonework. This is Diwan-e-Khas, load-bearing building, and you can see the inside of this Diwan-e-Khas. This is a huge building constructed 450 years ago, and still it is in good condition. And if you consider the roof, it is also flat roof is provided at that time without any RCC and steel. This is BMC building at Mumbai, and this is our own example, BMB Amravati. I think it is more than 90 years old, still it is serving the purpose. Now, if we plan properly, then load-bearing building can also serve the purpose. Now we know example of government engineering college buildings, some of the buildings of government engineering college, due to some reasons, we have to reconstruct it. There is a problem on the part of soil investigation, design, or construction. But the ultimate result is we have to reconstruct it within, say, 30-40 years. One of the Professor Tarun from he's of opinion that for monumental buildings such as colleges, university, where we want life, say more than 100 years, we must think properly. Say for IIT building also, within a span of 30-40 years, there are problems. So some strengthening measures are required. So at time of construction of buildings, we must think about the life, and suitable type of building must be considered so that it must have higher life. Load-bearing structures. It is common misconception that load-bearing buildings are obsolete and not preferable, but they can be better solution in many cases. For small structure, low rise, where spans are relatively small, and say if say bearing capacity is available at shallow depth, uh, and good quality materials such as stones and bricks are available locally, then load bearing structure will be a better solution. When spans are quite large and we want multi-storied building, more than 4 or 5 storied building, then because of earthquake, the load bearing building will not be a proper solution because the thicknesses required will be quite large. Uh, so it will not be better. Now, if you look at the performance of load bearing buildings in Kilari, now some of you might be knowing that in 1993 there was earthquake in Kilari, magnitude around 6.3. So Kilari was the epicenter, and this is the building constructed near epicenter, very close to the epicenter. In this building, there was lintel band provided. Roof slab acts as a band, and there was no damage to this particular building. So if proper precautionary measures are taken, the load-bearing building can behave in better fashion than the RCC building. This is an example of stone building with earthquake features, and there was no damage to this particular building. This is UCR masonry building. There was no damage to this building also because it was provided with a lintel band. In 2001, there was earthquake at Bhuj, and you must have seen the performance of frame structure. Now this is the load-bearing structure, two-storied load-bearing structure. It is in stone masonry. So because it was constructed as per the principle of it, because it was constructed as per the hello, am I audible?
Yes, sir.
Okay. So this is two-storied load-bearing building. Now, whatever principles which are there for load-bearing building, these principles were followed in this particular building, and that's why there was no damage to this building. It was 60 kilometers away from the epicenter, but its behavior was very good. There was no damage. Now we'll see some calculations for load-bearing building. Now these calculations will be helpful for frame structure also because some parts need this calculation. Now you can observe here, this is the compound wall at MIDC Amravati, and it was overturned. It is half brick wall with some intermediate pillars, and because of it, it was overturned. Now let's try to understand stability for compound wall. This is the compound wall, and it is subjected to wind load. So width of wall is 0.23. Height of compound wall is, let's say, 1.65 meter. So if we calculate the load, then 0.23 is the thickness, and in running length we will consider 1 meter for calculation. So 0.23 into 1 into 1.65. So we'll consider a block of length 1 meter, height 1.65 meter, and density of brick with plaster, let's say it is 20 kilonewton per meter cube. So this is the weight 7.59 kilonewton for 1 meter length of wall. We can calculate the wind load as per IS 875. Now I will not explain this. You already know. We'll have to calculate the various coefficient, and by using IS 875, we can calculate the value of horizontal pressure which will be 1 kilonewton per meter square. Now here we considered location as Amravati. So there is a horizontal pressure of 1 kilonewton per meter square. If I consider 1 meter length, then 1 kilonewton per meter square into 1 meter. So loading will be 1 kilonewton per meter. The wall will be considered fixed at the base and free at the top. So WL square by 2 will be value of bending moment, and bending moment will be 1.36 kilonewton meter. So because of wind load, the moment is 1.36 kilonewton meter. So let's try to calculate the stresses, the base of the wall. So this is the elevation, 1.65 meter height. Now this is the thickness is 0.23 and length is 1 meter. Calculate the value of stresses at the base. Now consider calculation the value of load for 1 meter length comes out to be 7.59 kilonewton, and bending due to wind load it comes out to be 1.36 kilonewton meter. So for calculation of stresses at the base, we can first calculate the value of direct stress, which will be P divided by area at the base, and that value comes out to be 0.03 Newton per meter square. Now, because of direction of wind, tension will be developed on this face and compression on other face. And by using M by Z, we can calculate the value of stress. Now, remember, this vertical axis will be neutral axis, and moment of inertia will be 1 into 0.23 cube by 12. So by doing the calculation M by Z, we can calculate the value of bending stress at the base. So on right hand side, it is this value, and on left hand side, same value will be there. On right hand side, it will be tensile, and on left hand side, it will be compressive. So if you calculate total stress, that is direct plus bending, then on right hand side, the final stress comes out to be 0.121 Newton per millimeter square tensile. So naturally on this phase, tension will be developed. If you consider the permissible stress in brick, then normally no tension is allowed in brickwork. But under wind or earthquake case, in case of freestanding wall, some amount of tension is allowed, that is 0.1 Newton per millimeter square. But the actual value of stress is more than this. So this particular compound wall is not safe. So what is the conclusion? Even if you construct 230 millimeter thick wall, freestanding wall for compound wall, if height is only 1.65 meter, it is not safe. So what is the solution? We have to go for thicker wall, or the best way is to go for frame structure. We have to construct columns at regular interval, and some beams or connecting copings will be required for making the compound wall safe. Same thing is possible for parapet wall also. You might be knowing that in 1996 there was cricket match at VCA Stadium, Nagpur, and parapet walls were constructed in half brick wall. Now, because of crowd, there was a pressure on the parapet wall. These walls were not properly connected to the main structure, and because of that, there was overturning of parapet wall. And because of falling of this parapet wall, there were fatal casualties. more than 5-6% died in that particular incidents. So even a small structure, a parapet wall or compound wall, these are also important, and we must take sufficient care. Otherwise, there might be problem. Now we must understand the behavior of structure under horizontal load. Now we have seen that this is the wall under horizontal forces. This wall is a weak wall. But if you consider this particular wall and this is the direction of force, this is forces are acting in the stronger direction. This wall will be strong if forces are like this. If I consider a room, then there are four walls. If I consider this, for this direction of earthquake or wind, these two walls will be weak, but another two walls will be strong. If four walls are properly connected by a proper bond or some bands, then its behavior will be better. But for that, the dimensions of these walls, unsupported dimensions, are also important. Now, whatever thing which we are discussing for load-bearing structure, it is also applicable for frame structure. Whenever there are openings, it will reduce the strength. So the position of openings are most important in case of load-bearing building. See, whenever there are cross walls, it will support the long wall and the behavior will be better. If very long walls are there, then these walls are not stable. There must be some framing element. Otherwise, overturning of these walls will be possible. Now, there are some specifications given. This is a very good book, a manual of earthquake resistant non-engineered structure. Now here, what should be the position of openings, total length of opening for single solid building and double solid buildings. All these things are given. So without doing calculation, you can plan your load bearing buildings. There are many more things given in this particular book. So this is the book, Manual of Earthquake Resistant Non-Engineered Construction. So here many more things are given. So you can study these and you can design your load bearing structure. Then there is another book by Dr. A.S. Arya. This will explain you the calculation for load bearing buildings. And this is the code IS 1905. This will give us the guideline for permissible space in tension, compression, and all other things are given. Now you can have all these material from this website, National Information Center for Earthquake Engineering. And if you want, you can purchase from this website also these books. Then there is another type which is quite interesting, which is called as confined masonry. Now there is a difference between the frame structure and confined masonry. In case of frame structure, we have seen that load will be transferred from slab to beam and from beam to column. Now in confined masonry, there are no beams and column, they are bands. Load will be transferred from slab to the foundation directly, just like a load bearing building. Then what is the use of these bands or vertical members, or vertical RCC member? Now they will be useful in resisting the horizontal effect of earthquake or wind. During horizontal forces such as wind load or earthquake, tension will be developed, and if you provide these type of bands, then they will be most effective. The behavior will be better than the frame structure. Now there are number of examples. At IIT Gandhinagar, they have constructed hostels and staff quarter by using this confined masonry. 4 solid buildings were constructed using confined masonry. at IIT Gandhinagar. So behavior will be better and earthquake resistance will be also better in case of confined masonry. This is the book which is available for design of confined masonry. Now, after considering load-bearing building, we'll consider frame structure. Now, first we will consider a simple plan, say dimension 15 meter by 7 meter, very small halls. Now we'll see the arrangement of beam and column. Now there are number of solutions possible for arrangement of beams and column. Now let's see various options. Say this is 7 meter by 15 meter hall. No, I don't want intermediate beams. So only one slab panel will be there. Only one slab panel. So naturally the panel dimensions are 15 meter by 7 meter. So Ly by Lx is 2.414. It is more than 2. So it will be one way slab. And for calculation of depth, it will be 7,000 divided by 20. This is the modification. This is the L by D ratio for simply supported condition given in IS 456. And modification factor depending upon the percentage of steel. So we will have requirement of depth equal to 291 millimeter. And if you add half diameter and clear cover, then the thickness requirement will be around 320 millimeter. So in option 1, design of small hall, if I consider 7 meter span for one way slab, then thickness required will be 320 millimeter. Now let's try some other possible options also. This is first option where only one panel is considered. Thickness of slab required will be 320. Now second option, if I provide intermediate beams so that the span roughly center to center distance is 3 meter, then this will be one way continuous slab and span for slab will be 3 meter. If I calculate thickness required, then it will be 110 millimeter, or depth required for the slab will be 110 millimeter. In third option, I'm dividing into 4 panel. Now the dimension of panel is 7 by 3.75. So it's less than 2. So it will be again two-way slab. And depth required here will be 125 millimeter. If I provide central beam here, that is secondary beam, then there will be 8 panel and thickness required will be 110 millimeter. Now there are 4 options and you can think about more options also. Naturally, we will not go for this. Why? Because 320 millimeter thickness is quite large, and in that case, the amount of dead load will be very large. Second option is one-way slab. The one important point is in case of one-way slab, we'll have to provide main reinforcement in main direction and we'll have to provide distribution steel in other direction. But in case of two-way slab, we'll be providing main reinforcement in both direction. So there is no need of distribution steel. And that's why whenever it is possible, if you go for two-way slab, the structural behavior will be better. Deflection will be less and the amount of steel required will be less. So this third and fourth option will be better. Fourth will be better. Thickness required will be 110. There is no point in providing panel dimension less than 3 meter or less than this, because in any case we'll have to provide minimum 100 millimeter thickness from vibration control point of view. So normally we must decide a slab panel in such a fashion so that thickness of slab is around 100 to 150 millimeter. In some exceptional cases, we may go for higher thicknesses. We must restrict up to 150 millimeters so that design will be economical. And then there is no point in providing very small panel because in any case we'll have to maintain minimum 100 millimeter thickness. Then let's see arrangement of columns and beams. Now, if you for first option where only one-way slab is provided, theoretically we can have only say two beams B1 and beams B2. Main beam will be B1, B1, and only 4 columns will be sufficient theoretically. Let's see what is the effect of this. Generally, we will provide L by D, that is span by depth ratio, overall depth ratio for beam between 10 to 15. So depth of beam required will be 1500 millimeter or 1.5. So for this beam, for span equal to 15 meter, depth required will be 1.5. So there is no problem in designing. But what is the problem? If you consider this panel, the dimension of length of unsupported brick panel will be around 15 meter. And in this direction, it will be 7 meter. And if you consider wind or earthquake, then these panels, brick panels, will not be stable. Let's see. This is one building, load-bearing building at MIDC Amravati. These dimensions are quite large. It's unsafe. Why there was a failure? Because the brick, the dimensions are quite large. If you do the calculation for wind load, the stresses at the base will be quite large. So same thing is possible here. If you provide only 4 columns, then the brick panel will be wind or earthquake. Even for a small wind pressure of around 0.25 kilonewton per meter square, there will be and that's why these panel dimensions are important. Many times we cannot have closely spaced column. So in that case, we'll have to provide some structural members. Say vertical, we can call these dummy column and bands, so that these whatever partition walls or walls which are there, these walls will be properly connected to the main structural element. Now you can see here, there was a brick panel, and during construction, initially this concreting was not done, and these panels were not supported. So because of small wind or even small jerk, these brick panels can be easily overturned. So dummy columns and bands are essential whenever brick panel dimensions are quite large. Now you can see here, this is the dummy column. It must be connected to the main structural element, that is the top beam, bottom beam or slab, and then some horizontal elements are also required. In horizontal element also some reinforcement is required because there will be tension developed. So horizontal reinforcement as well as vertical reinforcement is essential. These vertical reinforcement, they must be anchored in the main structural element, such as in this case beam. If you are not anchoring this, then there is no use. The entire panel will be overturned along with this dummy column. So these are the all important points which you must consider. So either we must have a closely spaced column so that unsupported length of the panel will be divided and panel will be safe. Or if it is not possible, then for making this wall safe, we'll have to construct some vertical and horizontal bands. So here for first option, I have shown the number of columns here, and then in this panel also intermediate column will be provided. Then for option 2, uh, positions of beams are shown. The orientation of column is also important. This span is quite large, 7 meter. So if you place this column like this, longer dimension parallel to the long beam, then that will be economical use of a column. So orientation of column is also important. Whenever it is possible, we must place it properly. Now let's consider structural planning and design for major projects. Now we have seen a very small problem of 15 by 7 meter, but that is very small problem. In case of major work, lot of persons will be involved, and there must be good interaction and understanding among owner, structural designer, or and contractor. Now the another important point is importance of structural configuration. If we have a poor configuration to start with, all the engineer can do is to provide a band-aid, improve a basically poor solution as best as he can. Conversely, if we start with a good configuration and reasonable framing system, even a poor engineer cannot harm its ultimate performance too much. This is the quote by late Henry, a noted earthquake engineer from USA. So what is important? So we must have proper structural arrangement. Now many a time planning will be done by architect. There are various principles. If we follow these principles, then the building will be better. But many a time it is not possible. So as a designer, we can have some changes. So suppose L-shaped building is required. Then we can observe here at this junction, there will be stress concentration and failure is possible at the junction. So to avoid this, if we divide this building into two parts with a seismic joint, we have to provide sufficient separation gap so that from the elevation or functional use point of view, it will be L-shaped building. But from structural point of view, these two blocks will behave as a different block, and the response will be better. So whenever we must have a simple shape. If some complicated shapes are there, to improve its behavior, we can provide seismic joints, and with the help of that, we can change the behavior and performance of building will be better. Another most important point is importance of strong column and weak beam. Now we must have a very strong column, because you know that if there is a failure of column, entire building will come down. In some beam, if there is a problem because of ductility, overall structure there will not be failure. But unfortunately, what is observed, the most of the time it is observed that people will try to provide minimum size of column due to various reasons. They will try to do economy on the dimensions of column only, and that is most dangerous. We can see here the example from 1985 Mexico earthquake. Now, definitely it was weak column. Now columns are not at all visible, all slabs, and all columns are crushed. Now you can imagine the situation. What will be the plight of person who are occupying this particular building? So we should not take any chance regarding the dimensions of structural elements such as columns and structural walls, etc. Now you might feel that whatever example which I have shown, it is of uh, Mexico. It is not possible in Vidarbha or Maharashtra. But there are problems. The only thing is these are not explained to the general public. Now there was construction of a gymnasium hall at Parshi Takri Akola. The columns were erected. This is inside view and this is outside view. Because of the wind load, there was overturning and there was failure of column at this particular level. You can see the collapsed columns. So in case of gymnasium hall, height is quite large and each and everything must be properly designed. No thumb rule will be applicable. The reason for failure, the sizes of columns were not sufficient. There were several problems and because of that there was a failure. So uh, everywhere these things will be there. If you do not take proper precautionary measure, then definitely there will be problem. The another important thing is regarding the lift. Most of the time for multi-story building, we need structural members for lift. Many a time, instead of providing RCC wall, columns are provided. Let's see what is the difference between the column and RCC. When 4 columns are provided and brickwork is provided as per the specification, we must have 23 centimeter thick wall, brick wall, or you can have 0.15 millimeter thick RCC. Now, if I consider 1.8 meter long RCC wall, then I can calculate in the moment of inertia for that for this RCC wall by normal equation, and this is the value of moment of inertia for this wall. And if I calculate moment of inertia for these 2 columns, then this is the value. And now if I calculate moment of inertia of wall, ratio of moment of inertia of wall to moment of inertia of column, then this ratio will be 44 times. So this wall will be very strong. So whenever it is possible, try to provide RCC wall, at least for lift core. It will increase the resistance of a structure and its resistance against wind or earthquake will be very, very large compared to RCC. It is 44 times stronger than these 2 columns. Now you can see here how strong it is. These are the photographs from Bhuj earthquake, which indicate the strength of lift core. I think this core and staircase was going on like this. So entire building collapsed, but this lift core is in intact condition. Same thing is in the other picture also. The lift core or RCC shear wall will be very strong. The another important point is it must be properly connected to the structural walls. Structural slab is properly connected to slab, it will support entire building. If RCC walls are provided, shear walls are provided, they are not responsible for the roof area, but these will be responsible for entire building. That is the most important point which we must remember. So we must provide structural wall whenever it is possible. Now we have seen the importance of structural walls and columns. So proper arrangement and proportioning of structural walls is most important. And we must provide structural walls and column at appropriate location. It will increase the resistance. If we consider the earthquake forces given in the code, then these forces are a fraction of whatever actual force which will be acting on the building during the severe earthquake. It is considered that it is only 10% of maximum force which will be acting on the building. So if you are not considering this small force also, then the stability of building will be in danger. Now, structural design is most important, and that is quite vast topic. I have considered some planning aspect, proportional aspect. I can talk for hours together, but it's not time. So I will, to conclude, I will explain you some of the feature for structural design. We'll have to select preliminary sizes and arrangement of column, beams, shear wall, and bracing. Now we'll have to use latest codal provision, and most of the things are already explained in the code. For earthquake, it is IS 1893 of 2016. RCC, you already know, IS 456. For steel, it is IS 800. For high-rise building, IS 16700. For ductile detailing, that is the most important part for earthquake resistant, that is 13920. Then for wind and loading, it is IS 875. So we'll have to select structural arrangement, and that must be proper. Then by considering various code, we'll have to follow the codal provision. Then we'll have to perform analysis. You already know how to apply loads due to dead load, live load, wind load, and earthquake. Definitely, it is not possible manually. We'll have to use some software. There are many commercial software available. We'll have to use this software. After performing the analysis, we'll have to go for checking the behavior, such as stresses, deflection, and modes, etc. If performance is not satisfactory, then we'll have to redesign. So we'll have to change some dimensions of the column, shear walls, bracings, etc. So we'll have to redesign the things, and again we'll have to check this. This will be iterative process, and after design is satisfactory, we'll have to prepare a detailed working drawing along with the construction notes. So this is the structural design procedure. I think there was a workshop arranged in Pote College regarding the use of software. I hope you must be knowing the how to use this. So this is in short about structural planning and design. Thank you. Thank you very much.
Thank you very much, sir. Thank you very much, sir, for informative session. Sir, before starting for a question and answering session, there is one note for the participants that feedback link will be shared in the chat section of Zoom box. Link will not be shared on mail ID. The participants have to fill the feedback link, and those fill the feedback will receive the certificate. Sir, some questions are there from the participants. Hello, sir.
Yes.
Sir, the first question is, while renovating old load-bearing structure like old WADA, what precautions to be taken?
While renovating the
old load-bearing structure, sir, like WADA.
Now, definitely, say renovation means if we want some openings, etc. Then for providing opening, we'll have to provide some lintels. So depending upon the type of renovation required. If you want to remove some walls, then some girders, etc. will be required. So unless we know the exact renovation plan, it's difficult to answer.
Okay, sir.
But
sir,
it is possible.
Okay, sir. The next question is, if groundwater table is near the foundation, what is the effect on design of foundation?
First we must consult the soil expert. Uh, Many times, if groundwater table is high, then they will recommend lower bearing capacity. So that effect we will have to consider in design. That is regarding bearing capacity. That is the only one thing. If there is a basement, then only uplift pressure will be there. For normal building, only we'll have to consider whatever bearing capacity is recommended by the expert. That we'll have to take into account. Otherwise, there is no problem. Now we must also see whether there is a possibility of unequal settlement, etc. That will depend upon the type of soil.
Okay, okay, sir. Sir, again, one question is there. Can we convert already built a load bearing structure into frame structure?
See, if load bearing building is there and if it is serving the purpose, then there is no need to convert into frame structure. But suppose if you want some modification, some wall is to be removed, then you may provide additional structural elements such as vertical columns and beams, etc. Otherwise, there is no need. We may construct further also if condition of wall is very good.